Every single day, hospitals and clinics across India are generating just tons and tons of waste. Now, most of it totally harmless, but there's this small fraction that is, well, it's incredibly dangerous. So in this explainer, we're going to follow the high-stakes journey of that hazardous waste through a system that's designed to protect every single one of us. Let's dive in and see how it all works.
I mean, it's a question we probably don't ask ourselves very often, right? It's kind of out of sight, out of mind. But where does all that stuff actually go? Turns out, its journey is one of the most critical and yet almost invisible processes in all of public health.
And here's exactly why this matters so much. While most of the waste from a hospital is pretty harmless, basically like our regular household trash, it's that other 15%. That's where the huge risk lies. I want you to think of it like a really concentrated cocktail of infectious, toxic, and hazardous materials. Stuff that absolutely has to be handled with extreme care.
Okay, so what are we talking about here exactly? Well, the official definition is actually really broad. It covers pretty much everything, from a major hospital to your local vet clinic, all the way to a research lab. The rule is simple. If it's generated while providing care or doing research, it falls under these special rules.
All right, let's get into the specifics. What exactly makes this 15% so dangerous? Well, the risks are very real, and they're also incredibly diverse. Yeah, this is not just your average trash. It's what's called a dynamic reservoir of risk. I mean, these bags could contain anything from superbugs, those multi-drug resistant bacteria, to really toxic chemotherapy drugs. And then, of course, there's the most direct threat of all, a single accidental needle stick that could transmit diseases like HIV or hepatitis B. The stakes are really high.
So how do you manage all these different risks? Well, India has a really comprehensive system for this, which got a major update back in 2016. And it all starts at the exact moment the waste is created. The whole thing is built on a simple but really powerful idea. You have to segregate it right at the source, and you do that using a 4-color code.
Now, the crucial thing to get here is that this isn't just about sorting trash. It's actually about deciding its final destination. So here's how it breaks down. Yellow is for anything that has to be completely destroyed by fire. We're talking human tissues, soil dressings, lab cultures. Then you have red. That's for contaminated plastics like IV tubes and gloves. Those can be disinfected and then recycled. White is specifically for sharps, needles, scalpels, things like that, which get sterilized and then shredded. And finally, blue is for things like glassware and metal implants, which can also be disinfected and sent for recycling.
This color code, it actually reveals a kind of hierarchy of risk. The yellow stream is definitely the most hazardous overall. But even within that, there's a category that's even more dangerous: cytotoxic waste. This is the stuff that comes from cancer treatments. These drugs are so incredibly potent that they need their own special label, and they have to be incinerated at over 1200 degrees Celsius just to make absolutely sure they're gone for good.
Okay, so sorting the waste into the right colored bag, that's really just step one. Now, a highly controlled journey begins to make sure that waste gets from the patient's bedside to its final treatment, both safely and accountably.
So inside the hospital, this waste is moved around in dedicated covered trolleys. It is never mixed with general trash. Then it's kept in a secure, isolated area before it gets picked up. And here's where a key innovation from the 2016 rules comes in. Every single bag gets a barcode. This is a game changer. It creates a digital chain of custody so you can track that bag from the hospital ward all the way to the final treatment facility. This is huge for preventing any kind of illegal dumping or misuse.
And you gotta remember, the clock is always ticking. To stop decomposition and prevent dangerous microbes from growing, infectious waste, the anatomical or soiled stuff, it cannot be stored for more than 48 hours. That's the rule. If for some reason it has to be kept longer, it has to be put into cold storage.
All right, so after being tracked and transported, the waste finally arrives at a common biomedical waste treatment facility. And this is where the final battle is fought. This is where we go up against the pathogens and the toxins using two main weapons: fire and steam.
Now, these two technologies really represent two different philosophies of treatment. On one hand, for that super hazardous yellow waste, the goal is simple: complete and utter destruction. That's incineration. On the other hand, for the recyclable red and white waste, the goal is disinfection. That's done through autoclaving, which basically uses high-pressure steam to kill all the pathogens, making the materials totally safe to be shredded and recycled.
And when we say incineration, we are talking about serious heat.
The secondary chamber of these incinerators has to hit at least 1,050 degrees Celsius. It's this intense temperature, plus a rule that says the gases have to stay in there for at least 2 seconds, that guarantees the complete destruction of the really nasty pollutants, things like dioxins and furans, before they have any chance of escaping into the air.
You know, autoclaving is way more than just a steam bath. It's a precise science. There are very specific combinations of temperature, pressure, and time that are required to guarantee sterilization. But here's the cool part. How do you know it actually worked? Well, the ultimate test is a biological one. They actually put in these little vials of Jubacillus sterothermophilus spores. These are some of the toughest little organisms on the planet. And the logic is simple. If the autoclave cycle is powerful enough to kill them, then you know for sure it's effective against any lesser pathogen.
So, this whole system we've been talking about, it's all built on a foundation of rules and regulations. And these aren't static. They're constantly evolving to keep up with new science, new technology, and of course, the growing needs of our healthcare system.
If you look back, the rules for this have steadily gotten smarter and tougher. We had the first framework back in 1998. That was modernized in a big way in 2016, bringing in that scientific segregation and digital tracking we talked about. And it's not stopping. Upcoming guidelines are going to require real-time emissions monitoring for incinerators. And soon, large hospitals will be classified as bulk waste generators, meaning they'll have to process their own organic waste on-site. That's a huge step for sustainability.
So you might be wondering, who makes sure all of this actually happens? Well, the whole system is regulated by the state and central pollution control boards. These are the authorities that grant the licenses, that conduct the inspections, and they have the power to penalize any facility, whether it's a small clinic or a massive treatment plant, that doesn't comply with the rules.
When you step back and look at it, what's the ultimate purpose of this whole elaborate system? I think this quote just sums it up perfectly. Every single color-coded bin, every barcode scan, every validated autoclave cycle, every piece of this puzzle is part of a critical firewall. It's a firewall built between the hospital environment and the community's ecosystem, designed to contain the hazards and protect all of us.
So the rules and the technology, they give us a really robust framework. They build the firewall. But we all know a firewall is only as strong as its weakest point. And in the end, the success of this entire system really comes down to the daily discipline of every single healthcare worker. So the question we're left with is this. The rules provide the firewall, but is our discipline strong enough to maintain it?